Okay, we're going to take a look at an algebra or a couple of algebra examples when you have angle bisectors. These are pretty similar to what happens with the midpoint problem, so we're not going to go into too much depth here. But anyway, you could get a situation like this. EF bisects GED, so you're going to want to draw yourself a picture. So we've got, we'll label G, we'll label E, and we'll label D. And then we're going to sketch an angle bisector. You don't need to use your compass and straight edge for this. We're just doing a sketch so we kind of know what's happening in this problem. So sketch right down the middle, and I'm going to put in some arcs to show that we've got congruence here. And in this situation, we've got EF bisecting GED. So let's put point F on GED. Alright, so now they tell us that GEF has a value of X, and they tell us that DEF has a value of Y. And since we know that this angle bisector splits these right down the middle into two congruent parts, we know that those angles have equal measures, and we're going to be able to make the equation X equals Y. Obviously, the expressions you get later are going to be a little bit more sophisticated, but the general idea is that you're setting the top part equal to the bottom part because they're congruent. Alright, so this example probably almost looks identical to the last one, but it's a little bit different, and the difference is going to be important. So we're going to take a look at this one. We're going to sketch the angle bisector again, and again we have angle GED being bisected by ray EF. So again, we can make our angle congruent to our other angle because it's being bisected. This time we have GED, that's the entire thing, has a value of X, and we also know that GEF has a value of Y. So there's a couple equations that you could make up here that would satisfy this situation. Both of these guys are going to have to be Y since they're equivalent to each other. So one thing that you could do is you could double Y, and that ought to be equivalent to X, or you could half X, and that ought to be equivalent to Y. Now you're probably going to want to choose this equation when you're working algebraically because mathematically nobody really wants to multiply by a fraction. So those are the two scenarios that you're going to have, where you double the smaller part to get the whole thing, or in a situation like this where you're given expressions for these two parts and you're just going to say, all right, we know that they're equal, so X equals Y.